12 adults, 18 kids are in the prom program planning committee. A smaller group of them, 5 people only. We want a subcommittee of 5 people. Needs to decide on the theme. How many different ways can a smaller group, the subcommittee, consists of at least 4 adults? Those is at least at most. Just so we look at those ones. The at least and the at most. Please pay attention to what we want. So it doesn't say that these people have specific jobs, right? So we know it's a team. We know it's a combination. So they're just on the subcommittee or they're not. And we want at least 4 adults. So method 1 is figure out what it's actually asking for. So at least 4 adults. So that means we could have 4 adults or 5 adults. And it says at least 4. Think of it in money. If you can't do it at least $4, you need at least $4. You need $4 or more, right? Why did I stop at 5 adults? Why wouldn't I do 6 when there's actually 12? There's only 5 people on the committee. You always have to stop at the number that the committee has, right? So I can't take 6 adults because there's only 5 people allowed on the committee. So at maximum, I can max out at 5 adults because I can't do 6 adults. That would be too many people on the committee. Now, this is just like when I had said to you yesterday, like 3 queens, but I needed 5 cards in my hand. I needed 3 queens and 2 others, correct? So for this one, yes, it's great I have 4 adults, but I need to have 4 adults and what else is there? Kids, right? 1 kid. I still need to have a group of 5. And this will be 5 adults and 0 kids. Do I have to write the 0 kids? Not really. But I always need to have my group have the amount of people that it needs. Now, how can I guarantee getting an adult? What do I have to choose from? The adults, right? Guarantee a girl, choose from girls. Guarantee king, I choose from king. So if I want adults, I have to choose from adults. So I have 12 adults. So I'm going to do 12, C, 4, and means multiply. Kids, that is 18. 18, C1. Or is the plus sign. 5 adults, so now I still have 12, C5. I don't put down any adults because this is the separate groups case doesn't have. And then I could go times 18C0. But 18C0 is just 1, so there's no point in putting it. You can. Now put it in your calculator. So there's 9,702 subcommittees that I can make, or 4, that have at least 4 adults. Okay? We're going to look at method 2 for this one because it's not faster. I'll show you method 2 of the next. This is the one method you can do. You just do what it asks for. So it says at least 4 adults. This one is at least 1 adult. So if you do directly what it asks for, at least 1 adult would be 1 adult, or 2 adults, or 3 adults, or 4 adults, or 5 adults. You need at least 1. Which means you have 1 adult and 4 kids. Or 2 adults and 3 kids. Or 3 adults and 2 kids. Or 4 adults and 1 kid. Or 5 adults. 1 adult, 2 adults, 3 adults, 4 adults, 5 adults. Does it make sense? Because there's at least 1 adult in a cases of each option. This is a whole bunch of cases though, right? So it's going to take us a while. There are 12 adults and 18 kids, right? 12 adults. Yeah. So we're going to do 12 C1 times 18C4 plus 12C2 times 18C3 plus 12C3 times 18C2 plus 12C4 times 18C1 plus 12C5. When you're done, type it in and go together. So there's 133,938 subcommittees that would have at least one adult. And we can always do this, just doing it the way that's at least one adult. But there's a whole bunch of cases, and if there's a lot of cases, there might be a way that you can do it faster. And I remember how I said back when we were doing permutations and people sitting together, and I said, how many ways can people not sit together? So you took the total number of ways and subtract off the ways they could sit together. You can do the same thing here. You can do all the ways, all the certain subcommittees you could make, okay, minus off the opposite of that. So how can I do all of the subcommittees possible? How many people are there in total? Kids and adults. There's 30. There's 12 adults, there's 18 kids, so there's 30 total. So method 2, I'm going to do it here. So you could do 30 C5. So that would be all the possible subcommittees I could make, not caring whether they're kids or adults. If they're all adults, it could be all kids, it could be a mixture of kids and adults, right? So 30 C5 is the total. And then I subtract from it all the cases that don't fit that. And then what's left over are all the cases that do. So at least one adult. What's the opposite of at least one adult? At least one adult is one adult, or two adults, or three adults, or four adults, or five adults. What's the opposite of at least one adult? What's the opposite of having at least one adult in the group? Having no adults in the group. So we could do minus 0 adults and 5 kids, right? That's the only other option I have. The opposite of at least one adult is no adult. So I would just go 30 C5 minus, do I have to do the 0 adults? Do I have to do 12 C0? 12C0 is I have 12 people, I choose none of them. How many ways can you do that? One way. Pick none. Okay? So 12C0 is just one. You don't actually have to show it, but if you want to show it, you can. And you go 12C0 and times 18C5. What should you get when you put that into your calculator? 133,938. It's exactly right. So doing it directly gives you a whole bunch of cases. Sometimes it's faster to do total minus the opposite of what it's asking for. So try this next one directly. So do at most 2 adults and do actually at most 2 adults. At most 2 adults means what? At most $2 means $2 or less. So at most 2 adults means 2 adults or less. How far can you go? 2 adults or 1 adult or no adults. That's only 3 cases, so it's probably faster to just do it correctly. So try that one out. All right, so at most 2 means 2 adults and 3 kids, we need 5 total, or 1 adult and 4 kids, or 0 adults and 5 kids. But remember, we don't really have to deal with adults, we don't want to do it. So you're going to do 12 C2 times 18 C3 plus 12 C1 times 18 C4 plus 18 C5. Or you could do that 12 C0 times 18 C5. You know the answer? You should. You know people? And it gives you a calculator. Caleb, you know the answer? You agree? All right. So doing the complement of this wouldn't be faster. The complement of this would be at most 2 adults is what? 0, 1, 2, right? The complement would be 3, 4, 5. So it would be 3 adults, 4 adults, or 5 adults. So it would be 3 cases, right? And this is 3 cases. But that one you have to subtract from the total. So sometimes it's faster to do just that. Some people are like, I do not like the backwards way. Don't ever do it. There's no problem. You can always do just direct. Okay? You don't have to deal with people. All right. So it says no. Sometimes one method is more efficient than the other. It's best to know how to do both, but if you don't, you know how to do one really well, that's okay. So here, example 7. The student council decides to form a subcommittee of 5 council members to look at how funds raised should be spent on students of the school. There are 11 student council members, 5 male, 6 female. How many different ways can they form these different subcommittees? Now, the moment I say exactly, it's just an acceptable standard question. The moment I say at least or at most, it's a standard excellence. And 25% of your diploma is standard excellence questions. So they're the harder type questions. Sometimes the standard excellence questions I find in the diploma are actually easier. They're in the at least or at most, but it's not a hard at least at most question. Where they can make a different question in terms of comes way harder. That doesn't equal these points, right? So just because it's standard excellence doesn't mean it's actually harder. Most of the time it is, but not always. So exactly 3 females wouldn't be a standard of excellence. It's exactly 3. This is a catch though. Exactly 3 females. How many are in the committee? In the subcommittee of this one? 5. Is it always 5? No. It just has to be 3 females. So you have a 5-person subcommittee, 11 total, of which 5 are males, 6 are females. In the end, we need to have 5 people in our subcommittee, right? So if this says exactly 3 females, what does it indirectly tell you? Exactly 3 females and exactly what? You have 5 people. Exactly 3 females and exactly 2 Have it? Yeah. Examples are easier, but you have to remember that what people often do is they'll just go, okay, I have 6 females, I choose 3, and then they're done. That's not 5 people. You didn't choose a 5-person subcommittee, you chose a 3-person subcommittee, so your answer's not wrong, it's not right, and it's going to be there. So this is a common error, number 1. Just forgetting that you have to have 5 people, okay? But now we realize it's going to be 2 males, so 5 males, and we're going to choose 2. I want you guys to finish that one and try B and C. 63, 5, 6, 200. So we report 200 subcommittees with exactly 3 females and exactly 2 males from our 11, right? At least 3 females. Fernando, what does that mean? At least 3 females. So 3 females. And 2 males, yeah. Or at least 3. So 3 females or 4 and 1 male or you need at least 3. So 3, 4, or 5. It's not a 5 because it's a 5-person subcommittee, right? So 6 females, 6 C 3 times 5 males, 2, 2. 4 plus 6 C 4 times 5 C 1. Or 6 C 5. Did anyone get the answer? Pick up on those. Okay. 281. Everyone agree? Now we have at least 1 female. So we could do this as 1 female, 2 females, 3 females, 4 females, or 5 females, right? Or we could do what we did on the last one. We could do, and if you did that, that's fine, just keep your right answer. Or we could do 11 total, choose 5, and at least 1 female. The opposite of that would be no females. So subtract off 0 females and 5 males. You didn't do this thing to have the same answer, that's absolutely fine. You could have done 1 female and 4 males, 2 females and 3 males, 3 females and 2 males, and then 4 females, so 1 male, 5 females. Okay. Minus females would equal 60, 0, or we could just do 5 C 5. What do you get? You could have done it this way, and I'll show it. You could have like 1 female and 4 males, or 2 females and 3 males, or 3 females and 2 males, or 4 females and 1 male, or 5 females. It will take longer, but you could do it. You get the same thing. You get 6C1 times 5C4 plus 6C2 and 5C3 plus 6C3 times 5C2 plus 6C4 times 5C1 plus 6C5. So just a bit more work, but still 460. Okay, let's flip over. We'll look at card ones. Consider a standard deck of 52 cards. How many different 5-card hands can be formed with at least 1 red card? So we still need a 5-card hand. So at least one red card means 1 red, or 2 red, or 3 red, or 4 red, or 5 red. But we still have to have 5 cards. Here we only have 1. So before red, or 1 red and 4 black. I don't know why the black and red are opposite colors. I just see. 2 reds and 3 black. 3 reds and 2 black. 4 reds and 1 black. 5 reds and no black. Right? At least 1 red. So 1 red, or 2 reds, or 3 reds, or 4 reds, or 5 reds. And we don't have to stop. Sometimes if it says at least 4 queens, let's say, you'd go 1 queen, 2 queens, 3 queens, 4 queens. You can't do 5 queens because we only have 6. Okay? Sometimes you have to stop yourself after. So, how many reds are in a deck? Half the deck. 2 divided by 2 is 26. So we'll have 26 of each. So it'd be 26 C1 times 26 C4 plus 26 C2 times 26 C3 plus 26 C3 times 26 C2 plus 26 C4 times 26 C1 plus 26 C5. Or we could do the subtraction method, right? Total, so there's 52 cards C5. Subtract the opposite of this. At least 1 red, the opposite of at least 1 red is no red, right? So all black. So it would be 5 black. So 52 C5, black cards are 26, so 26 C5. That's it. So yes, you can know this one method and be fine. That one just happens to be a lot faster. So what's 52 C5? $2,533,180. You try that at most 2 kings. Okay. At most 2 kings means 2 kings or 1 king or 0 king. The opposite of a king is an other. I just call them others because every other card but a king. So the 2 kings and 3 other cards, or 1 king and 4 other cards, or 0 kings and 5 other cards. So what I like to do here is I like to go, there's 4 kings in the deck. That helps you out. Just like males and females, if there's 5 males and 6 females and all that stuff. So there's 4 kings, and how many others? There's 62 cards in the deck, 4 of them are kings. So how many others? 48. 52 minus 1. So we're going to do bracket 4C2 times 48 C3 plus 4C1 times 48 C4 plus, do you have to go from 0? No. If we go 4C0? Yes. We need to do 1. And then 48 C5. And that will get you 2,594,400. Now, handshakes. Handshakes are always a combination because if you think about it, you're choosing two people to do a handshake, right? Does the order matter which hand comes in first? Does that change the handshake at all? Like, if I meet up with someone quicker, is that a different handshake? No. So those two that you're choosing, just like the five of the subcommittee we choose, for example, the five of the subcommittee we've chosen so far that didn't have jobs, they have specific jobs, didn't matter what order we chose those five, it still gives the same subcommittee. It doesn't matter what order we pick those two hands, it still forms the same handshake. So handshakes are always combinations. So here we have, and whenever I've never seen a handshake that involves more than two hands. You try it out, but like you'll be like, is it two hands or three hands? It's usually two people doing a handshake. If there's three, it's a little weird, but it happens. But I haven't seen it on the phone, so there you go. So we have during the PE hockey tryout, all the players met on the ice after the last practice and shook hands with each other. As a grade, we determined the number of players who attended the tryout if there were 300 handshakes in all. So what people often do here, common error, is they go 300 C2. 300 handshakes, that's the total answer, right? So that's what it equals. Your answer is 300. It's not 300 people shaking hands. It's 300 handshakes, that's it, right? So it equals 300. It's not 300 C2. It is C2 because it's two hands and a handshake. What are we trying to find out? Okay. So some people put into the formula and spend numerous years doing this. If it's something this quick, I would just start. I know guess and check is sometimes seen as terrible, but I would. If it's a multiple choice, puzzle, more answers in with this. Okay? Right? The next response you have to go. N has to be at least what number? In this question, what does N have to be at least? 2. You can't choose 2 from something that doesn't have 2 things. This has to be at least 2 C2, right? It couldn't be 1 C2. You can't have one thing and choose 2 of them. That doesn't make sense, right? So your N has to be greater than or equal to your R value. So you can go 2 C2, 3 C2, 4 C2, 5 C2, 6 C2, 7 C2, keep going for your 300. Or you can fill it into the formula. I didn't fill it into the formula to show you that, but you could guess. So the formula is n factorial over n minus r, so n minus 2 factorial 2 factorial. Equals 300. 2 factorial is just 2, right? That was the right answer. So what you can do is multiply by 2. We got 2 up there. So now I have n factorial over n minus 2 factorial equals 600. And it's expand like I would have done before. N factorial is a bigger one, so I'm going to expand it until I get n minus 2 factorial. And n minus 1, n minus 2 factorial over n minus 2 factorial equals 600. Those cancel. Then I expand, so I get n squared minus n equals 600. What I tell you always have to do when you have a quadratic, move everything to one side instead of equal to 0. It goes into your head like 800 times last year. Quadratics, 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 quadratics. You have to, the only way you can solve a quadratic is when it was a squared or a cubed or a fourth, which is going to be zeros off. Everything to one side set it equal to 0. So we get n squared minus n minus 600 equals 0. And you have to factor that. Is it 15 or 14? 16 or 15? I'm just trying to be different. 25 and 24. I'm going to close to 15. 25 and 24. If you go 25 times 24, you get negative 1. Or negative 25 times negative 25 times 24, you get negative 600. Negative 25 plus 24, you get negative 1. So n minus 25, n plus factorial. So the answer is 25. So some people will say, well, my decimal checking took forever. This isn't super fast either. So either option works, right? Sometimes this is faster if this is like a really, really large number. The other thing I want to go over, it's not on here, I will go to the top of the page, is if I say to you, there are 10 soccer teams, who play every other team 3 times. How many games? How many teams play each other in a soccer game? One soccer game. You know, like a trifecta, like three soccer nets, and like they 3 people play. How many teams play each other? I know you can answer this. If you don't raise your hand and don't make me fuzzy. Gianna, how many people play in a soccer team? Soccer team. 2. So we have 2 people that play. Okay? So if I do 10C2, I take a 10C, and I choose 2 to play at a time. That means that home and away doesn't matter, right? It doesn't matter if you're home or you're away. That's playing each other once. Okay? So 10C2 is how many ways that the 10 teams can play each other once. So if I want twice, I'm going to times it by 2. If I want 3 times, I'm going to times it by 3. Now, that would be the answer to this one. If it said that 10 soccer teams play each other twice, sometimes on the diploma the answer is 10P2, and they're right. 10P2 is the exact same answer as 10C2 times 2. So 10C2 means playing each other once, right? And you times that by 2, and I'll get the same answer as 10P2. Why? 10C2 times 2 is the exact same answer as 10P2. What does the P mean? Order matters, right? So if order matters, then home and away is different than playing away and home, right? So 10P2 means I can position the teams this way, the same team, say it's HA and comp, that's one game, or if I position them this way, that's a different game, right? The P means the order in which you have those 2 teams matters. Who's home and who's away matters. So 10P2 means every other team playing every other team twice. So home and away is different than away and home because order matters. So 10P2 is actually the same as 10C2. I like 10C2 personally because it doesn't matter how many times, it just times by that amount. But I do have to explain that 10P2 because sometimes everyone's like, well, 10C2 is the answer, and they only have 10P2 there as an option, and that's wrong. Although it's not. It's actually the same answer. Okay? If you place those close. Now, we're going to go on to, so you guys can try 10 and 11, and then I have another little example for how to do it later home. And then it'll be full. So this is how many reasons of the word poppy. So whenever I get a word, I go P, O, P, P, I, E, X. So remember to divide by 3 factorial all my answers. Did you do that? It's permutation because it's a word, not a combination. Without restrictions. So 1, 2, 3, 4, 5, 6, 7 letters. I have 7 options, and 6, and 5, and 4, and 3, and 2, and 1. You have to remember, it's without repetition. You can't repeat letters. There's only so many letters in that word, and you can't repeat them. You get like, it's like if you had the word poppies, all the letters on a separate card, right? You only have that many cards. You can't like find an extra piece somewhere. That's as many as you have. Okay? So it is without repetition. Without being said. Remember we told said without repetition. You have to know that. Divided by 3 factorial. What's 7 factorial divided by 3 factorial? 840. If each reason begins with a P, 1, 2, 3, 4, 5, 6, 7. Now if you go with a P, how many P options do I have? 3. I don't go, okay, well, it doesn't look any different if I don't have that. And then I just treat it as if they all look different and then divide by 3 factorial. Get rid of all my issues where they don't look different. Now I have 6 letters left. 6, 5, 4, 3, 2, 1. Divided by 3 factorial. And that's 360. If the first 2 letters are P, does it say the third can't be P? No, it just says if the first 2 letters are P. It does make a difference if it says the first 2 letters are P and the third one is not P. So it just says the first 2 letters are P. 1, 2, 3, 4, 5, 6, 7. Okay. So I have 3 options for the first one, since it can be a P. Then I have 1 P there, so 2. Okay. Then I have 5 letters left. 5, 4, 3, 2, 1. Divided by 3 factorial. Every single one of these is divided by 3 factorial. And that is 120. If all the P's are to be together, say together as a part. Now, just as together. 1, 2, 3, 4, 5, 6, 7. And place them together, and then I'm going to move them. So 3, 2, 1. 4 letters up. 4, 3, 2, 1. And they have 5 places to go. They go here, which is 1 way. 2, 3, 4, 5. Remember, it's also more than this. Over 3 factorial. The standard is 6 times 5 factorial over 3 factorial. Which I could actually say is 6 factorial over 3 factorial. If you can see it, 10.6. 20. Now this is different. The first letter is P, and the next one is not P. The first one is P, and the next is not P. How many P's do I have? 3. How many not P's do I have? 4. How many letters do I have left now? 5, right? I have 1 here and 1 here. So I have 5 letters left. So 5, 4, 3, 2, 1. 5 by 2 factorial. And that is 240. This is a class consists of 5 girls and 7 boys. Committees to be formed consisting of 2 girls and 3 boys. Determine the number of ways that you can teach this committee if there are no further restrictions. So they want 2 girls and 3 boys. Do these people have jobs, specific jobs to themselves? No, so it's going to be a C. Only I can guarantee in girls, choosing from girls, boys, choosing from boys. So there's 5 girls, and then go 5C2, and I can multiply 3 boys, 7C3. Is 350. This is kind of like that coach one where like we have to pick the coach. So with 1, choose 1, take coach, choose coach, right? It says Johnny, the principal's son, has to be on the committee. Johnny, the principal's son, has to be on the committee. So we put Johnny. We still go back and have 2 girls and 2 girls. And now how many boys? 2. Because Johnny's one of the boys. We need 3 boys total. We already have Johnny. Okay? Let's feel good with this. Let's feel good to this. Johnny is 1 choose 1. There's only one, right? You take Johnny, choose Johnny. It's the only way you're getting Johnny. The girls is 5C2. The boys, everyone tells me it's 7C2. Which is wrong. That's common error 101. That would happen all the time. There's not 7 boys left anymore. How many boys are left? 6. Everyone remembers to take Johnny off of this boy. So 2 boys here. But they forget to take Johnny off the total. Right? We've already, Johnny's here. He's the boy. He's taken off of this boy. And he's taken off of the total amount of boys. So there's 7 boys. So there's only 6 left. 6 to choose. So 150. Another question that I want to show you, just a quick one. So I can give you, say, a circle, and on that circle I have dots. However many, it doesn't matter. Get them really close together and zoom out. And I ask you how many triangles can be in there. So a triangle needs 3 lines, right? To make a triangle, it's a triangle. So say I go like this. That would make a triangle, right? Yeah. Now, does the order in which I draw those lines, those 3 lines, make a different triangle? So if I draw them like this, 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 is that a different triangle than if I go like this, this, and then that? No. So the vertical order doesn't matter, does it? No. So, how many dots do I have to choose from? Well, 1, 2, 3, 4, 5, 6, 7. And I choose 3 at a time. And then I can find out how many triangles I can make from all the vertices. If I just want straight lines, right, then I would do 7C2. If I want quadrilaterals or 4-sided figures, then it would be 7C4. Okay? And give you the total amount that you can draw. So the rest that is for homework that I didn't have assigned on here, so all of this is good except for 10. I don't still like 10. Oh, okay, take it off. What's also due for tomorrow is that quiz. We're going to take that at the very beginning of class. So the first time is to discuss it, then we're going to take that quiz at the beginning of class. And we're going to do binomial theorem. Now, we're going to have Friday to work on this hand, and you guys, we're going to have Friday to work on it, but it's due in a Friday.